Okay, y'all, so we're actually in chapter 7 today, and we're doing the ellipse. And so as you can see on the screen, an ellipse is like an oval. It's going to work a lot like a circle, except that ovals don't have a consistent radius. So we'll talk about how you figure out like the up-down distance and the left-right distance, because you're going to graph it basically the same as a circle. It'll just be an oval instead. So the technical definition of an ellipse is a curved line forming a closed loop where the sum of the distances from 2 points called foci to every point on the line is constant. So I'm going to explain to you what a foci is, but we're not going to worry about what a foci is. So if at some point in your future you're dealing with conic sections and you need to have heard the word foci or focus before, I'm explaining that, but we're not going to use it because it's not necessary to get a graph, which is our main goal. Okay, so if we look at, not that. Okay, let's see the minimum. Here we go. All right, so this Math is Fun website that y'all played on when you were little kids has some actual like real math, not just goofy games. So it has this little applet where you can see that a foci is a focal point. There's 2 of them in an ellipse. So there's going to be like a center right here. We'll worry about that. That's going to be helpful for us graphing. Foci we're not going to worry too much about, but just so you understand what they are. There are these 2 focal points, or 2 foci, a focus, another focus, so plural foci, where if you take the distance from one of them to the edge and the distance from the other one to the edge, if you add those 2 numbers together, it's constant all the way around. So as I move this, so if you look down here from F to G, so if I take FP plus PG, so this distance plus this distance, y'all should be able to tell that this is blue and this is red, then this distance from here to here never changes. It's just how much is red and how much is blue changes as we move around the edge of the ellipse. You can see that they're still making up the same distance together. It's just that one of them takes up more than the other as you move around. So foci are these magic little points in the middle where the distance from the 2 of them to the edge added together is constant all the way around the ellipse. Okay. Whether you understood that or not, it's not important for what I need you to know. All right, so what I do need you to understand is that for an ellipse, we are going to, basically it's one equation, but for some reason they want to make it more complicated than it needs to be. So we're going to simplify it when we start graphing, but an ellipse can be written like this, or it can be written like this. If we have a vertical major axis, which is going to give us this picture, then the y has the bigger number underneath. So this a and b, those are just numbers squared. So like 2 squared, so 4, or 3 squared, so 9, whatever. But whichever one of them is bigger is going to be the one that's considered the major axis, the longer axis. So if your major axis is your vertical axis, making it an up and down oval, then the bigger number will be under the y. If the major axis is the horizontal, then the bigger number will be under the x. So these are the same equation. It's just a matter of who has the bigger number underneath them. So to find the length of the major axis, you have to know the square root of a and double it. The radius is just a. So just like with the circle, the square root of a tells you how far to go left or right or up or down, depending on who it's underneath. And you would just double that distance to get the length of the whole thing. So like the diameter of a circle, but in this case, it's the major or the minor axis because they're not the same. Okay, so you see how this looks a lot like the equation of a circle, except that we have fractions. That's because for an ellipse, we have to be equal to 1. With the circle, you're equal to the radius. But since it's not the same for an ellipse, we're going to be equal to 1, and we have these denominator numbers that give us our kind of like a radius. Okay, so let's take a basic one. So this one, there are no parentheses. So that means that we are going to have a center at 0, 0. And then your bigger number is under X, but I'm not going to worry with calling them A or B or anything like that. I'm going to talk about vertical and horizontal. I'm really not even going to talk when it comes to graphing about who's major and who's minor, because it's not that crucial. And I think it's easier for y'all to understand if we just talk about vertical and horizontal. So underneath the X is going to be a left-right distance. So that's a vertical axis. And actually, let's just do this because it's less writing and you don't have to think that much. This is what I'm going to say. The distance that I'm going to go left and right is the square root of 16, so 4. Underneath the Y tells me how much we're going to move up or down. So the distance I'm going to move up and down is the square root of 4, so 2. All right, so to graph that, we're just going to put our center at 0, 0, go out 4 both ways and up and down 2. And then we're going to do the best we can to make this look like, I would say like a football, but like make sure it's rounded on the ends because it doesn't really come to a point. So make sure that you round yourself through here and do the best you can to hit all of your points. And there we go. So that is our ellipse. I don't know if your directions say anything about domain and range. I honestly don't remember. But if you wanted to do domain and range, it's just like a circle. Domain is far left to far right. So it would be -4 to 4. Remember, we put brackets because there's actually points at those ends. And then the range is bottom to top. So -2 to 2. All right, again, read your directions when you're doing your assignment. I don't remember if it asks you for domain and range. I would assume that it does somewhere, but I didn't put that in my directions on this slideshow. Okay, so again, foci, they're in there. We don't need to know how to find them or where they are because it's not crucial, because our goal in this class is, can you graph some conic sections? Or can you write the equation if I give you some info? So we're going to keep it simple and basic so that y'all have ideas what's going on. And then if in the future you need more information and they expect you to already have it, please email me, call me, whatever, and I will tell you everything that you need to know. Okay. So number 2, again, we're going to keep it kind of simple, but we need to remember that for an ellipse, we're supposed to look like this. So we have to be equal to 1. And X and Y on the same side before we can graph. So for standard form. So the first thing I want to do is move the Y over here with the X. All right, and then to get this to be 1, we're just going to divide by whatever that number is. Now, usually the textbook and I are going to be friendly to you, and your fraction should reduce pretty easily. A lot of times they like flip-flop. Like 7 times 5 is 35. So when I reduce this, I get x squared over 5. When I reduce this, I get y squared over 7. All right, so for this one, you see how the number under y is bigger? That means this one's going to be taller than it is wide. For the one we just did, the number under the x was bigger, so it was wider than it is tall. So this one has a horizontal major axis, and number 2, we're going to have a vertical major axis. Okay, so in order to graph, what information do we need? We need to know where the center is, so we know where to count from. And then we need to know how far do we move to the left and the right? How far do we move up and down? All right, so this one's going to be yucky numbers, but that's okay because we're just going to do the best we can. So left, right is going to be the square root of 5. And I don't know what the square root of 5 is. So with my calculator, I get about 2.2. So roughly 2.2. Or not. 2.2. Okay. So up, down is the square root of 7, because that's the number under the y. And that is going to work out to be 2.6. All right, so from 0, 0, we will go a little more than 2. to the left and to the right. And then up and down, we're going to go a little more than halfway between 2 and 3. Again, I know when you're doing decimals, perfection is not something I can expect. I just need it to be generally in the right place. 2.2 has got to be closer to 2 than the 2.6 is. All right, so then we do the best we can to draw an ellipse. And this one looks almost like a circle, but that's because our vertical and our horizontal radii are almost the same. I have no idea what I just with my hands there, y'all. Sorry. Okay, so moving on. Okay, so what happens when there are parentheses? Well, all that affects is your center. Pay attention, because in case they switch these around, you got to make sure that you do the number with the X and the number with the Y when you're at your center. All right, so the center for this one, you remember it's coming out of parentheses, so we're going to change the sign. So it'll be at -2, +3. And the reason for that is the original, like, generic version has minus signs. But also, like, literally in your whole life, anytime you're taking something out of parentheses in a math class, the sign's going to change. Okay, so we have our center, and then the number under the X tells us how far to go left and right. So the square root of 16 is 4. And then the number under the Y says how far do you go up or down. So the square root of 9 is 3. All right, so -2, 1, 2, 3. And then we're going to go out 4 and up 3, down 3. So this one, you have the bigger number under the X, which means you have a horizontal major axis. And so since that radius is 4, the major axis is going to be 8 units long, because 4 plus 4 is 8. Your minor axis, your minor radius was 3, so your minor axis is 3 plus 3, 6. Okay, keep that in mind, because in a few minutes I'm going to give you information. You have to write your own. So that's why I'm pointing that out. All right, so do the best we can to draw something that resembles an egg. Not really, because eggs are like skinnier on one end than the other. Anyway, so there we go. All right, so we'll do domain and range on this one again, just to make sure you have another example. All right, so always brackets for ellipse and circles, because they're completely closed figures. So we have used every point from this side to this side, and I did that like you could see where I was pointing, from here to here. So what is that? -6 to +2. All right, so do you see how, like, I can get this -6 if I just do -2 minus 4 and then -2 plus 4? That gives me these numbers. All right, so if I take my 3, if I do 3 minus 3, that means I have a 0, and 3 plus 3 is a 6. So my range should go from 0 to 6. And if you look at the graph, that is true. So you don't have to have a graph to tell me the domain and range of an ellipse. It's just easier to count, but you can use your info and figure it out. Okay, y'all. So what happens when they don't give me the standard form? They give me a general form. All right, so we had our question last week about circles on what the general form would look like. How do you recognize that it's a circle? Well, for a circle, remember that you had to have x squared plus y squared, so both of those had to be positive, and then these coefficients had to either be 1s or the same. All right, so for an ellipse, you know it's an ellipse when it's in general form, because x squared and y squared are positive, but their coefficients don't match. If their coefficients don't match, that's what's going to cause you to have a distance that's different left, right, and up, down, which is going to give us an oval instead of a circle. All right, so attendance question: how do I look at general form and know it's an ellipse? And the answer is x squared and y squared are positive and have different coefficients. All right, so how do I turn that in to standard form so I can graph? Completing the square. All right, so I'm going to have to do that work down here, because otherwise I'm not going to have enough room. So here's what we're going to do. I'm going to try to do a couple of things at one time. So make sure you're looking and listening and not trying to write, those of you that are actually taking notes. You can pause and then write after you've listened to me explain. All right, so I'm going to take these x terms and I'm going to put them together, but I'm also going to factor out their common factor of 9. So I'm going to say 9 and then x squared minus 2x plus blank, close parentheses. All right, so I have this set up to complete the square. That's what the plus blank is for. But I divided the 9 and the 18 that were on the x's by 9. So now I have a 1x squared and a negative 2x. All right, so then for the y's, we're going to take out a 16 because they have to have coefficients of 1 for general form. That's how we get the numbers on the bottom. So I've got to take out whatever they have in common. And I'm not going to give you anything that doesn't divide like pretty nicely. So don't worry about that. All right, so the y's have a 16 and a 64. So we take out 16. That's going to give us 1y squared plus 4y. Then we need our plus blank to complete the square. Move the 71 to the other side. And remember, you have these plus blanks that you've got to counteract from the other side. Okay, so the goal is to put a number here so that this factors to parentheses squared, and this 9 is just kind of sitting there. Okay, so half of 2 is 1, so we get x minus 1 in our factored form. 1 squared is 1. This is always a plus, by the way, because you're squaring something, so you're always going to get a positive. But this is in parentheses with a 9 on the outside, so we got to times it by 9 to put it over here. That's the one new thing from what you did on Friday with the circles. All right, so for the y's, you have plus 16. We're trying to factor this to parentheses squared. So half of positive 4 is positive 2. 2 squared puts a 4 here. 4 times a 16 puts a 64 on the other side. All right, so then we've got to add 71, 9, and 64. So 144. Now, again, I'm not trying to make life more difficult than it needs to be. So when you add these up, you should get something that works with these two numbers. I mean, there might be a rare occasion where that's not the case, but not very likely. All right, so for it to be the standard form of an ellipse, you have to be equal to 1. So we're going to divide through by that 144. And we are going to get, all right, so these reduce to 1/16 because 9 times 16 is 144. Let me double check that because in my brain it is, yes. Okay, so 9 goes into 144 16 times. So we get x minus 1 squared over 16. So 16 goes into 144 9 times. So we get y plus 2 squared over 9 and equal to 1. All right, so to graph, what is the center? So our center is positive 1, negative 2. So that's opposite of this, opposite of this. All right, so then we need to know how far do we go. What have I been doing first, y'all? Left, right, up, down? I don't remember. It doesn't really matter, but I try to be consistent so I don't confuse y'all. So how far do I go left and right? So the square root of 16 is 4. And then how far do I go up and down? Square root of 9 is 3. All right, so to graph, you have 1, 1, negative 2. Show out 4. And then up and down 3. All right, so again, the number under the x is the bigger. So we have a horizontal major axis. And that horizontal major axis is 8 because 4 plus 4 is 8. Yeah, I don't even understand what I just did for y'all. I cannot draw these. Some of y'all are sympathizing with me because y'all have told me how not pretty your circles were. You think ellipses would be easier, but they're really not. Okay, so that's good enough. All right, so again, domain is left to right. So you can count to that it goes from negative 3 to 5, or you can say 1 minus 4 is negative 3, 1 plus 4 is 5. You can count that it goes from -5 to 1, or you can say -2 minus 3 is -5, and -2 plus 3 is 1 to get your domain and range. Okay, excuse me. So we have a few more. Can we write the equation? When I ask you to write the equation, I'm going to want you to write the standard form because that's easier. And I'm going to either give you a picture or I'm going to give you the information that you need or a way to find that information. So in order to write it, you're going to need to know the center. So if we look, this one is at 2, 1. You're going to need to know how far did we move left or right. So if you look at this, that's 1, 2, 3 units. And you need to know how far did we go up or down. All right, so making sure, I wrote different colors, I can color code. Here's the center. Our left-right distance is how far did we go left and right. And then our up-down distance, how far did we go up and down. All right, so to write the function, you're going to have x minus h squared over, I'm just going to say a squared because it doesn't really matter. In this case, it would be though. And then y minus k squared over b squared is equal to 1. So you are plugging in x minus 2. And then over here, you want y minus 1. Those numbers come from your center. All right, and then to get the numbers underneath, your left, right, you're going to square that number and it goes under your x parenthesis. And you're going to square your up, down, and it goes under your y parenthesis. Do you have to write this over 1? No, you don't. So really this could look like this. All right, so if I give you the picture, it's pretty easy. You just got to identify the center and how far did we go left, right, and how far did we go up, down, and put things in the right place. Not hard at all. All right, so making it a little more difficult, we're just going to give you some info. So I was kind enough on this one to tell you the center. We know that we have a major axis that's horizontal whose length is 12. So what that means is from major axis is horizontal. So that means I've got an ellipse that looks something like this. I know that the center is at 0, 0. Okay. I know that I have a horizontal axis that's 12, which means the distance all the way across here is 12, which means that the distance from here to here is half of that, so 6. And then it says that my minor axis is 6. So if all the way from here to here is 6, that means that this little piece is 30. I don't need you to draw this picture. I'm just trying to make you understand what information you're being given. All right, and then you know the center was at 0, 0. All right, so to write, you're going to say we have x minus 0 squared. So just x squared. And you have y minus 0 squared, so just y squared. And you know you're equal to 1. All right, so to get these underneath numbers, we know that our horizontal axis was 12, meaning that the radius was 6. So 6 squared is 36. All right, so our minor axis, since the major was horizontal, the minor has to be vertical. So that distance was 6. So half of that distance, or the radius part, was 3. So if I square that, I get 9. And I'm done. Okay, one last problem. We have endpoints of our major and our minor axis. So you can absolutely just look at these points and not draw a picture and know what's going on. Because if you look, you can see how the x is 7 here and the y is 6 here. So what do you think that means the center is going to be located at? 7, 6. You got it. All right, so then we know that the y values change from 9 to 3. So that means that this whole vertical distance is 6, which means we went up and down 3. We know that the x's changed from 5 to 9, which means the whole distance here to here is 4, which means the amount that we went left and right was 2. All right, so for those of you that were a little confused, let me draw you a picture so we understand. If I go to 7, 9, 1, 2, 3, 4, 5, 6, try that again. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I plot my points, I know that 7, 9, and 7, 3. And I know 5, 6, and 9, 6. So I have this oval, this ellipse that really does look like an egg. So what I know is that I have a center in the middle of those right here, which is going to be at 7, 6. Bear with me. 7, 6. Okay, and then we know that the distance that we traveled up or down should have been the same, but again, it's my tick mark, so whatever. 1, 2, 3. 1, 2, 3 is 3. And then the distance that we went left to right is 1, 2. 1, 2. All right, so you can draw a picture and it's easy, or if you just think for a second about what they gave you, that's also pretty easy. All right, so now to write out our equation, we're going to say, let's not use that color because I'm sure it's hard for y'all to see. We'll go back to black. So we can do x minus 7 squared and y minus 6 squared, and we're going to equal 1. All right, y'all, so I didn't pick an example where you had to change this to plus, but remember if your center is at a negative something, that minus a negative becomes a plus. And make sure that you don't leave minus a negative. Make sure you change it to a plus. Okay, so up, down, we moved up 3, down 3, so that means that we need a 9, because 3 squared is 9 under the y. And we went left and right 2, which means 2 squared is 4, goes under the x. Okay, y'all, so that's it. Make sure that you ask me questions if you have them. And in case you haven't heard otherwise from somewhere else, they have scheduled your graduation to be July 25th at CenturyLink, same times as before. And they're hoping that by then we can have normal crowds, but if not, we may have to have diminished crowds, but they're going to live stream it for people that can't be there or people that don't want to be in a crowd because they have higher risk of having complications if they get COVID. Anyway, so something to look forward to unless something changes or things go crazy again. Not that they've gotten much better anyway, but anyway, July 25th, mark it on your calendar. That's when you're supposed to graduate. And I will see y'all there. So we're almost done, by the way. If you want to make a little countdown like we were at school, you make those little paper chains like you used to make for Christmas trees and tear one off for every lesson. We only have 2 more lessons in a review. And you're done learning new material. 2 weeks from today is your final and you're done with my class. So that's good news, because I'm sure y'all are tired of watching videos of me and doing math. All right. See you Wednesday.